Hello and welcome. Well, we talk about creating objects. Yes, we can create objects, we can interact with them. Question, can we save them? And if we can, how? Okay, why don't we talk about variables? And we start to talk about temporary variables. Take a look. This is an example of how can we create a temporary variable in Smalltalk. Two vertical bars and the name of the variable in between. And if we want to create many variables, so we just use space to separate them. So start with lowercase. So in this particular example, we have created a variable name. And what is that? Well, we can think of it as a container which can hold any object. Again, I want to repeat any object. So we created a variable, we call it name, and this variable is capable of holding anything. Take a look at this code. So first line, create a temporary variable. So we have a box name. Second line, assign a string Tom to this variable. So from that moment on, variable name is holding string Tom. And third line, actually call an inspector on this variable. Why don't we try to execute it? And take a look. I will say execute. So that will execute the code. What do we have? We have string Tom, and it is a string object which is sitting where? In our variable name. So after we executed that line, string variable name become a string Tom. It's actually holding this string, and now we can interact with this string by specifying the variable name. And by the way, last line, that's a little bit unusual, so this is how we can programmatically call an inspector. Take a look. We have our object, string Tom, sitting in that variable name, and here we send a message to it, inspect. And that's pretty much same, but it's not pretty much, it's exactly the same as we do it from menu, calling inspector. It's just a programmatical way to call an inspector. Take a look on this piece of code. What is happening here? So first line is simple. We create a variable name. Second line, we assign string Tom to variable name. Okay, so now name is holding string Tom. And third line, we assign string Peter to exactly the same variable. So now variable name is holding Peter, string Peter. But what happened to string Tom? So it will be destroyed. So you don't really have to worry about this. Garbage collector will find this object, will find this string and destroy it later on. So after execution of third line, our variable name is holding string Peter. And of course we can inspect it if we send message inspect or inspect variable name. But what variable name holds by default? Take a look. First line, create a temporary variable. And now we want to inspect it. So why don't we do this? And I execute this and take a look. So name at that moment is nil. So, and remember nil, it's nothing. So it kind of makes sense. We have created a variable, but we don't put anything into it. So we have a box, but this box is empty. So an empty or nothing in Smalltalk, it is an object nil, right? Well, we know nil, it is an object, right? And we know what that object represents, nothing. And we know nil is an instance of something. Someone have created it, right? Remember, every object created by someone, by some class. And if we want to know who created nil, so of course we can open an inspector and see it this way. But what if we do this? Take a look. Well, in terms of objects, what's going on here? We have an object, this guy, nil, and we send a message to it, class. Again, we are talking to an object and say, we need your class. We send the message class, unary message, right? So we should get something back. what do you think we will get back? Well, it's actually a very simple question. We're asking for a class, so we're talking an object and say, hey, who is your class? Give us your class back. So, and we should get class of the receiver back. Well, in our case, receiver is nil, right? So we send message class to object nil. So, and we should get a class back who created class nil. All right, why don't we execute it and inspect the result? Let's try. I click inspect and I can see an inspector. Interesting. Take a look on the title, undefined object class inspector. So let's compare these two. I will inspect nil. Take a look. Can you see the difference between these two inspectors? So this guy inspect object nil, who happen to be an instance of class undefined object. But this inspector holding class itself. So class who have created nil. All right, and how do I know that? Take a look. Undefined object class. So in Visual H Smalltalk, if we can see word class, so clearly we're dealing with class. Here there is no word class, so we are looking at an instance of that class. Okay, there's a big difference, right? This is a factory who created this guy, and this is an object which generated by this factory. Okay, good. And as you can see, contents of this objects completely different. Well, this is just a nil object, and class has a lot of properties which populated in the left panel. So two completely different things. So once again, so we send message class to object nil, and we are getting a class who generated object nil. Yeah, we ask for class, and we are getting a class. Actually, any object, any instance of any class can respond on message class, because they all do know who created them, right? And they will send their class back and respond to that message. Okay, great. Now, what do you think will happen here? Take a look. What is happening here? There is an object. We send message class to it, and we are getting what? Class undefined object right here. And then we send message name to whom? To the class. See, it's not a cascading message, it's a combined message. So we send message name to result of previous execution. And result of previous execution is class undefined object. So as a result, we should get what? Well, let's see. What if I want to inspect the result? Take a look. What did we get back? We received this undefined object. What kind of object? Symbol. So let's think about this once again. What happened? So by sending this message, well, we actually can try it. If I inspect this, this gives us a class, right? So we have a class right here, and then we send message name to that class, and we get another object, undefined object, symbol object. Okay, so that gives us an information that class has, first of all, class, any class can respond to message name, and in response to that message, class will answer with its own name, which is a symbol object. All right, and what do you think about this? So again, we send class to nil, we get a class here. We send message name to this class, and we receive the symbol object, which actually a name of our class. And then we send message what? Size. To whom? To that symbol object, right? And that should, well, if our object can respond on that, it should give us a, well, what number, which is a size of this symbol. Why don't we try? Take a look. No error messages, nothing. Everything works perfectly fine. So we received 15. And what is this 15? 15, it is the size of name of the class who created object nil. Kind of complicated, but it's actually not. It's just a good example how can we use combining messages. After a while, it's become so natural, you don't even think about this. You know exactly what is happening here. Okay, back to temporary variables. Take a look on this code. So first line is simple. Create a temporary variable str. Okay, second line is simple. We created a string tom and assign it to our variable. So at that moment, our str variable is holding string tom. So in third line, kind of clean up, destroy this tom string inside of this variable. So make our variable empty again. So and tom, of course, will be destroyed by getters collector later on. So we don't really have to do that, but if you want to explicitly destroy contents of the variable, that's how you can do it. Take a look on this code. What do you think about this? Is it good? Bad? Anything wrong? Well, let's look at it. First line is perfect. Created a variable name, no questions. Second line, created a string tom and put it inside of this variable, no questions. Third line, kind of questionable. Well, technically, it will work just fine. Remember we said variable can hold any object. So before it was string there, now we put small integer. Technically, it will work okay. But take a look, name. The name of the variable, name, kind of give us a hint that variable is holding a string probably, someone's name. And if we put there small integer 25, it's kind of, well, deceive us in a way, like it's contradict the name of the variable, don't you think? So even though technically it is possible, it's probably not a good style to do something like that. Yeah, and what do you think variable name will hold after we execute these 3 lines? Well, it will be holding an object small integer 25. So if we inspect name, name will be small integer 25. Kind of confusing, don't you think? Take a look. This is a way how we can create 2 temporary variables. So we just have a vertical bars, and between them we put name of the variables. So this is a way, well, this line will create 2 boxes, box name and box age. Okay. Take a look on this. What do you think? Do you understand what is happening here? So first line is very simple. Create a temporary variable result. Well, second line, okay, so we'll store of result of execution 5 factorial print string. So what do you think result will hold? Well, why don't we inspect it? Take a look. Well, I will execute all this, right? So we will send message factorial to 5. Yeah, by the way, what's the order of execution? So 5 small integer. Yeah, we send message factorial to it first. Unary message, yeah, highest priority. Okay, that will give us 120. Then we send message print string to whom? To 120, right? So it's not a cascading messages. Okay, and we will get something from this, and that result we will keep in our variable result. And now let's say we're not really sure what is going to be there, so we want to inspect variable. Take a look. I specified the variable name once again, and if I click inspect, so we will be inspecting the last line contents of the variable result. Let's try. So what do we have there? So we have string object and string 120. Well, makes sense, right? So we calculated factorial of 5, which is small integer 120, and then we send message print string to it, which is converted our small integer to string, and we take the string and we store it in our variable result. And when we open an inspector on it, here it is. We have a string 120. Take a look on this question, on this code, and Well, I actually have a question here. Take a look. We have two variables, right? Two temporary variables. But we have the same object and we store in two different variables. So what is going to happen? Is it possible to do or not? Well, what do you think? How do we know if our two temporary variables hold the same object? Like we specified 5 once and specified 5 twice, but is it the same object or different objects? Take a look. In Smalltalk, there is an easy way to check identity. So this will compare and give us true if receiver and parameter are the same object. So once again, in terms of object, there is a receiver, small integer 5 in our case. We send a message to it, this double equal, and we pass a parameter, right? So, and this message will give us true in case if receiver and parameter are the same object. Okay, why don't we try? Take a look. So we are getting true, meaning 5 here and 5 there actually the same object. So it's telling us that compiler is smart enough when they specify 5 twice and say, oh, it's the same 5. So there is basically no difference between one 5 and another. So there is no need to actually create another object in the memory. No, instead of I will supply already existed object to them and let them use it instead of creating a new one. So, and this is a way how we can check it. So what do we check here? We have two different objects. So we send message double equal to float object, right? Is it a float? Yes, it is. Float object. And we pass another float object as a parameter. So, and we want to say, well, when we specify float, well, is it the same object? Is the compiler smart enough to optimize it and do not create unnecessarily objects? Let's see. Yep, true is telling us that both these objects are the same, identical. What do you think about this? So we have two symbols and we check them for identity. Well, let's see. True. Great. And now tricky one. Take a look. Well, who's the receiver of the message? Double equal. Result of execution of this. Okay? And that's, what do we have here? We have one string, AB, right? And concatenated with another string, XY, well, with a hope of a message, comma. So basically this should give us what? Yeah, it's give us a string ABXY, right? Okay, great. Now we send message double equal to that string and we compare it to string ABXY, which is, well, we specified as it is. Now the question is this two strings equal? Oh, sorry, identical. Is it the same string or not? Let's see. False. Wow. So we're getting false. What does it mean? So that means that string created with this is a different string to this, even though the contents of those strings absolutely is the same. They're equal, but they're not identical. Well, I'm saying they're equal. What does it mean? Well, we can check for equality. How? Oh, very easy. This, right? So now we're asking a completely different question. We're asking contents of first string. Is it equal to contents of parameter? So we actually comparing context of those strings, not are they the same objects or not. So why don't we try? True. Absolutely. So equal give us true because first string and second string, they actually, well, same. Contents of the same. Well, as you can guess, identity check much faster compared to equality check. So this is why in system you will find a lot of identity checks. Well, take a look on this. first line is simple. Create two temporary variables, A and B. Now I missed several lines, so some code is there. And last line, check A double equal B. Let's imagine we are getting true from this. So what can you tell me about this variables, about contents of these variables based on that? Well, I would say that variable A and variable B, they both hold the same object. Would you agree with me? Well, you should be, because that's what it is. So if we check for identity two boxes and they show us, well, and this check gave us true, so it's telling us both objects hold, both variables hold the same object. All right. Now, what do you think about this code? So first line is simple, create a variable. Second line is simple. We assign string hello to this variable. Great. Now, how about third line? What is happening here? We are talking to the system transcript, this guy, right? So we want to show contents of variable str. So what do you think will happen? Well, why don't we try? I select it and execute it. Take a look. String hello appears in the system transcript. Why? Well, easy, because at the moment, after execution of this line, while variable str is holding string hello, it's actually become a string hello. So if we ask to show the system transcript, not a problem. So contents of this variable appear on the system transcript. Take a look. Two variables, A and B. A, we assign float 2.0. B is a small integer 5. Okay, works great. Now, what if we want to execute this? So let me select all this and inspect the result. So it's actually 4 lines of code, right? So inspect the result. Oops, my selection wasn't good, so we get a compilation time error. Okay. Okay, so let's try it again. And we want to display the result. Yeah. Float. Is it a float, right? It is a float 10.0.